You need to store confidential documents in an Amazon S3 bucket. The documents must be accessed only by users in your organization. How can you secure the bucket and ensure compliance? A. Use a bucket policy allowing public read access and rely on signed URLs for secure access. B. Configure an IAM policy that grants permissions to a specific IAM role and use AWS STS for temporary credentials. C. Enable S3 versioning and allow all authenticated AWS accounts access to the bucket. D. Use a CloudFront distribution with a public bucket for caching and set the S3 bucket policy to deny direct access. You are setting up an Amazon RDS instance for storing customer PI, personally identifiable information. What steps will ensure the database remains secure? A. Enable multi-AZ for high availability. B. Use AWS KMS to enable encryption for the RDS instance. C. Enable public accessibility for the RDS instance to allow external access. D. Use a bucket policy in S3 to store database backups securely. Your application is hosted in an Amazon VPC and requires access to an external API over the internet. What is the most secure way to allow outgoing traffic while preventing unsolicited incoming traffic? A. Attach an elastic IP to the EC2 instance. B. Use a NAT gateway in the public subnet and route outgoing traffic through it. C. Place the EC2 instance in the public subnet with a security group allowing all traffic. D. Deploy a bastion host for outbound traffic. Your application runs on an EC2 instance and needs to access data in an S3 bucket. What is the most secure way to provide this access? A. Store the AWS access key and secret key in the application's environment variables. B. Assign an IAM role to the EC2 instance with permissions to access the S3 bucket. C. Use a bucket policy that allows access from the public IP of the EC2 instance. D. Use a shared IAM user account for all EC2 instances. Your company has deployed a public-facing web application on an Amazon EC2 instance behind an application load balancer, ALB. How can you protect the application from SQL injection and cross-site scripting, XSS, attacks? A. Configure a security group to block SQL injection and XSS attacks. B. Enable AWS WAF on the ALB and use managed rule groups to filter malicious requests. C. Use elastic load balancer logs to identify and block malicious IPs. D. Enable VPC flow logs for traffic monitoring and analysis. You are designing a system where data must be encrypted during transit between clients and an EC2 instance hosting your application. How can you achieve this? A. Enable EBS encryption on the EC2 instance. B. Use an ACM-issued SSL/TLS certificate and configure HTTPS on your web server. C. Use AWS KMS to encrypt data at rest. D. Enable private IP addresses for EC2 instances. You suspect unauthorized access to your AWS environment. Which service can you use to monitor and identify suspicious activity? A. AWS CloudFormation. B. AWS CloudTrail. C. Amazon S3 Access Logs. D. AWS Trusted Advisor. You need to ensure that an Amazon RDS instance is not accessible from the internet. Which action should you take? A. Remove the public IP address from the RDS instance. B. Modify the VPC security group to allow access only from specific private IP ranges. C. Move the RDS instance to a private subnet in the VPC. D. Disable the publicly accessible flag for the RDS instance. You are troubleshooting performance issues on an RDS instance and need detailed metrics like IOPS, disk queue depth, and memory usage. Which feature should you use? A. Amazon CloudWatch Logs. B. RDS Enhanced Monitoring. C. AWS CloudTrail. D. Performance Insights. Your organization requires full control over encryption keys used for RDS. What is the best approach? A. Use the default AWS managed key to encrypt your RDS instance. B. Create a customer managed key, CMK, in AWS KMS and use it to encrypt the RDS instance. C. Use third-party key management tools to encrypt the database. D. Manually encrypt the data before storing it in the RDS instance. Your RDS MySQL instance is experiencing high read traffic. How can you scale the database to handle this load? A. Increase the instance size to a larger class. B. Enable multi-AZ deployment to balance read traffic. C. Create read replicas and configure the application to distribute read requests. D. Use an elastic load balancer to distribute read and write traffic across multiple RDS instances. Your team is migrating an RDS MySQL database to Aurora MySQL with minimal downtime. What strategy should you use? A. Take a snapshot of the RDS MySQL instance and restore it to an Aurora MySQL cluster. B. Use AWS Database Migration Service, DMS, to replicate the data continuously. C. Export the data to Amazon S3 and import it into the Aurora cluster. D. Create a read replica in Aurora MySQL and promote it to a primary instance. Your organization must ensure that all database login attempts and queries are logged for auditing purposes. How can you achieve this? A. Enable enhanced monitoring for the RDS instance. B. Enable CloudTrail logging for RDS events. C. Enable database activity streams. D. Configure query logging in the database parameter group. Your organization wants to mask sensitive data, like credit card numbers, in an RDS PostgreSQL database when queried by certain users, but retain the original data in storage. What is the best approach? A. Implement column-level encryption using AWS KMS. B. Use database roles and grant permissions to restrict access to sensitive columns. C. Use an RDS proxy with a custom Lambda function for masking data before sending responses to users. D. Implement PostgreSQL views to replace sensitive data with masked values based on user roles. Your e-commerce application uses Aurora MySQL as the backend database. You need to ensure minimal downtime during regional failures. Which solution should you implement? A. Enable multi-AZ deployment for the Aurora cluster. B. Use Aurora Global Database with replication between regions. C. Create cross-region read replicas and promote them during a failure. D. Take periodic snapshots and copy them to the secondary region.
Your RDS instance is currently in a public subnet, and you need to migrate it to a private subnet with minimal downtime. What steps should you take? A. Modify the subnet group of the RDS instance to include private subnets and reboot the instance. B. Create a read replica in the private subnet and promote it to a primary instance. C. Take a snapshot of the RDS instance, restore it in the private subnet, and switch the application to the new instance. D. Stop the RDS instance, modify its network settings, and restart it. A marketing campaign has caused a sudden spike in traffic to your RDS MySQL instance. How can you handle this traffic surge in real time? A. Increase the RDS instance class to a larger size. B. Create multiple read replicas and distribute the traffic. C. Enable multi-AZ deployment for better performance. D. Use Amazon Aurora Serverless instead of RDS MySQL. Your application receives too many connections errors when connecting to an RDS PostgreSQL instance. How can you resolve this issue? A. Increase the maximum connection limit in the RDS parameter group. B. Use RDS proxy to pool and manage database connections. C. Scale up the instance size to handle more connections. D. Create additional RDS instances and use an elastic load balancer to distribute connections. Your company has an on-premises data center and needs secure access to an Amazon RDS instance. What is the best setup? A. Enable public accessibility for the RDS instance and whitelist the on-premises IP range in the security group. B. Use AWS Direct Connect or VPN to establish a private connection and configure a security group to allow on-premises traffic. C. Use AWS Global Accelerator to route on-premises traffic to the RDS instance securely. D. Deploy an application proxy server in an EC2 instance and route all RDS traffic through the proxy. Your organization needs to audit all queries executed on an RDS PostgreSQL database for compliance. What is the best approach? A. Enable CloudTrail to log all database queries. B. Enable database activity streams and send logs to AWS CloudWatch or a third-party SIEM solution. C. Enable enhanced monitoring for OS-level activity tracking. D. Enable query logging in the database parameter group. You are designing a multi-tenant SaaS application that will host customer data on Amazon RDS PostgreSQL. Each customer should have logically isolated data but use the same database instance to reduce costs. What approach should you use? 100. A. Use RDS parameter groups to define customer-specific access policies. B. Use PostgreSQL schemas to isolate customer data and enforce row-level security, RLS. C. Deploy separate RDS instances for each tenant. D. Use a multi-AZ RDS deployment to create logical partitions per tenant. Your production RDS MySQL instance is experiencing significant performance degradation due to long-running queries. What should you do to minimize disruption while addressing this issue? 7. A. Enable enhanced monitoring to analyze the resource bottlenecks. B. Use performance insights to identify and terminate the long-running queries. C. Increase the instance size to handle the load. D. Create a read replica and redirect traffic to the replica. Your organization needs to allow an application running in a different AWS account to access an RDS instance securely. What is the best approach? A. Enable public accessibility for the RDS instance and whitelist the application's IP address. B. Use VPC peering to establish a private connection between the accounts and configure a security group to allow access. C. Share the RDS instance using AWS Resource Access Manager, RAM. D. Export the RDS database snapshot to the other account for periodic synchronization. You need to migrate an RDS MySQL database to Aurora MySQL while ensuring zero downtime. What is the best migration strategy? 32. A. Create an Aurora MySQL read replica of the RDS instance and promote it after synchronization. B. Take a snapshot of the RDS database and restore it to an Aurora MySQL cluster. C. Use AWS Database Migration Service, DMS, for continuous replication during migration. D. Enable Aurora Global Database and replicate the data. Your organization operates in a country with strict data residency laws requiring encryption keys to remain within the country. How can you ensure compliance with these requirements? A. Use the default AWS managed encryption key for the RDS instance. B. Create a customer-managed CMK in AWS KMS, specifying a regional key policy. C. Use third-party encryption tools to encrypt database content before storing it. D. Disable encryption for the RDS instance to avoid compliance risks. Your RDS PostgreSQL database is experiencing high write latency. How can you optimize write performance without disrupting read operations? A. Enable multi-AZ deployment to distribute write operations. B. Use an Aurora PostgreSQL cluster with a write-optimized instance class. C. Scale the instance vertically to a higher class. D. Implement partitioning and optimize indexes for high-write tables. Your application requires automated recovery from RDS instance failures with minimal downtime. How can you achieve this? A. Enable automated backups and restore the database when failures occur. B. Use RDS multi-AZ deployment and configure automatic failover. C. Configure a cross-region read replica and promote it during failure. D. Deploy a highly available application proxy to handle database failover. Your team needs to monitor and optimize query execution times on an RDS PostgreSQL instance to reduce costs. Which combination of tools should you use? A. CloudWatch logs and query logging. B. Performance insights and enhanced monitoring. C. AWS Cost Explorer and database activity streams. D. CloudTrail and RDS proxy. Your global e-commerce application uses an RDS PostgreSQL instance in a single AWS region. To improve disaster recovery, DR, and reduce latency for users in other regions, you must implement a solution with minimal write latency. What is the best approach? A. Use multi-AZ deployment and increase the instance size to handle more connections. B. Set up cross-region read replicas for better read performance and failover. C. Use Amazon Aurora Global Database to replicate data across regions. D. Configure manual backups and restore them to other regions during a failure. Your organization needs to integrate an external third-party analytics system with Amazon RDS MySQL for real-time data sharing. Data must be encrypted during transfer, and no database credentials should be shared directly. What is the best approach? A. Use an AWS Lambda function to push encrypted data to the third-party system. B. Use IAM database authentication and encrypt traffic with SSL/TLS. C. Set up an AWS data pipeline with server-side encryption enabled. D. Configure a read replica and provide the replica's endpoint to the third-party system. Your RDS MySQL instance is used by an e-commerce application handling a mix of OLTP, online transaction processing, and OLAP, online analytical processing, workloads. During peak hours, analytical queries significantly slow down transactional operations. What is the best solution? A. Create a read replica for OLAP queries and offload analytics. B. Scale up the RDS instance to a larger instance type. C. Enable multi-AZ deployment to distribute the workload. D. Use Amazon Redshift for OLAP queries and sync it with RDS via AWS DMS. Your organization operates in multiple countries, each with strict compliance requirements for data residency. You need to deploy RDS instances while ensuring data remains within the respective country. How do you design the architecture? A. Use RDS with default encryption and deploy instances in a central region for easy management. B. Create RDS instances in each required region and use customer-managed CMKs in AWS KMS for encryption. C. Deploy a single global RDS instance and configure cross-region replication with row-level security. D. Use Aurora Global Database with regional failover and encrypt with AWS managed keys. Your development team frequently uses Amazon RDS for testing, but the instances are often left running after work hours, leading to high costs. What is the best way to reduce these costs? A. Use AWS Lambda to stop RDS instances outside of working hours. B. Schedule RDS backups during off-peak hours to optimize costs. C. Enable RDS auto-scaling to scale down during off-peak times. D. Use Aurora Serverless instead of RDS for the development environment. Your team needs to update the schema of a production RDS PostgreSQL database, but downtime is unacceptable. What is the best way to perform the update? A. Take a snapshot, update the schema offline, and restore the database. B. Use a read replica, apply the schema changes, and promote the replica to primary. C. Use the blue-green deployment strategy with AWS DMS. D. Apply schema changes directly to the production database during low traffic periods. Your application's traffic is highly variable, with peak loads during business hours and minimal activity at night. How can you optimize the RDS costs while maintaining availability? A. Use on-demand RDS instances and scale up during peak times. B. Switch to reserved instances with the highest capacity. C. Use RDS proxy and manage connections efficiently. D. Use Aurora Serverless with auto-scaling enabled. Your RDS MySQL database is nearing its storage limit due to a large amount of historical data. Most of this data is rarely accessed but must be retained for compliance. What is the best approach to manage storage efficiently while meeting compliance needs? A. Increase the storage size of the RDS instance and continue storing all data in the database. B. Use Amazon S3 to archive historical data and integrate it with RDS using AWS Glue for querying when needed. C. Export historical data as snapshots and delete it from the RDS database. D. Create a separate RDS instance for historical data and migrate older records there. You have a highly concurrent e-commerce application using an RDS PostgreSQL database. Users frequently encounter deadlocks during checkout. How can you resolve this issue without significantly impacting performance? A. Increase the RDS instance size to handle more transactions. B. Optimize application logic to reduce transaction lock contention and use retry logic. C. Enable multi-AZ deployment to distribute transactions across instances. D. Configure database parameters to disable row-level locking. Your global organization has an RDS MySQL instance in Region A used for transactional processing. You need to replicate this data to Region B for near real-time analytics. Which strategy is optimal? A. Use AWS DMS to replicate the database in real-time to Region B. Create a cross-region read replica and configure it for analytics workloads. C. Use an Aurora global database and migrate RDS to Aurora for replication. D. Periodically export RDS snapshots and restore them in Region B for analysis. You accidentally dropped a critical table in your RDS MySQL database. The database is configured with multi-AZ deployment and daily, automated backups. How can you recover the table with minimal data loss? A. Promote the standby instance in multi-AZ as the primary. B. Use point-in-time recovery, PITR, to restore the database to a state just before the table was dropped. C. Restore the latest automated backup and retrieve the table data. D. Enable RDS read replicas and copy the table from a replica. Your RDS PostgreSQL instance faces sudden spikes in traffic during seasonal sales, causing query timeouts and application errors. What is the best solution to handle such spikes while optimizing costs? A. Scale up the RDS instance to a larger size during the sales period. B. Configure RDS auto-scaling to dynamically adjust instance size based on load. C. Add multiple read replicas and configure the application to distribute read traffic. D. Migrate to Amazon Aurora with serverless enabled. Your on-premises application needs secure access to an RDS PostgreSQL instance running in AWS. How can you design this connectivity? A. Enable public access to the RDS instance and whitelist your on-premises IP address. B. Use AWS Direct Connect and create a private connection to the RDS instance. C. Configure an SSH tunnel to access the database over a secure connection. D. Use AWS VPN to establish a secure connection and configure security groups. You manage a multi-tenant application on an RDS PostgreSQL instance. Some tenants complain about slow query performance. How can you identify the root cause and resolve the issue? A. Use CloudWatch to monitor database connections and CPU usage. B. Enable performance insights and analyze query performance by tenant. C. Increase the instance size and monitor if the performance improves. D. Use enhanced monitoring to check OS-level metrics for the instance. Your multi-tenant SaaS application is deployed in multiple regions using Amazon RDS PostgreSQL. Each tenant's data must remain in their respective region due to regulatory compliance, e.g. GDPR. How can you meet these requirements while optimizing operations and costs? A. Use one RDS instance per region and configure a cross-region read replica for failover. B. Deploy separate RDS instances for each region and enforce tenant isolation through logical separation in schemas. C. Use Amazon Aurora Global Database for multi-region replication and tenant-level data isolation using IAM roles. D. Configure RDS instance-level encryption using AWS-managed CMKs and deploy a single RDS instance globally. Your mission-critical application uses an RDS MySQL multi-AZ setup. During a primary instance failure, your application experiences a 1-2 minute failover delay, causing downtime. How can you minimize this downtime? A. Use cross-region read replicas to manually fail over during an outage. B. Enable RDS proxy to buffer connections during the failover process. C. Implement an Aurora MySQL cluster with a custom endpoint for automatic failover. D. Increase the RDS instance class to improve failover speed. Your production RDS PostgreSQL database requires a schema update to add new columns and migrate existing data. Downtime is not acceptable, and there is a risk of breaking existing applications. What is the best way to implement the schema migration? A. Perform the schema update directly during off-peak hours with a manual rollback plan. B. Use a shadow table approach. Create a new table with the updated schema, migrate data, and gradually switch traffic. C. Use AWS Database Migration Service, DMS, to migrate the schema in real time to a new database. D. Create a read replica, perform schema updates on the replica, and promote it to primary. Your RDS Oracle database supports an analytics application with unpredictable traffic patterns. During bursty periods, queries often fail due to resource contention. What is the best approach to handle such workloads while optimizing costs? A. Scale up the RDS instance to the next larger size during peak times. B. Configure a read replica and route analytical queries to the replica. C. Use Amazon Aurora with auto-scaling to handle variable workloads. D. Implement Resource Manager in Oracle to prioritize and control resource usage. Your organization needs to grant a third-party vendor read-only access to an RDS PostgreSQL instance in your AWS account. Security and auditability are critical. What is the best approach? A. Create a database user for the vendor and share the credentials securely. B. Enable public access to the RDS instance and whitelist the vendor's IP range. C. Use AWS IAM roles to grant cross-account access and enforce read-only permissions. D. Replicate the RDS database to the vendor's account using AWS DMS. Your multi-tenant application is experiencing slow query performance on an RDS MySQL database. Tenants frequently execute heavy analytical queries that affect all users. How can you optimize performance? A. Create separate RDS instances for each tenant. B. Migrate to Aurora MySQL and configure workload isolation using query routing. C. Use read replicas and route analytical queries to the replicas. D. Enable query caching and increase the instance size. You manage RDS instances for multiple business units in your organization, and each unit must be billed separately for their usage. What is the best approach to achieve this? A. Use AWS cost allocation tags and assign them to RDS instances. B. Set up separate RDS instances in each business unit's account. C. Enable detailed billing and manually calculate costs based on usage. D. Create read replicas for each business unit and track replica costs separately. Your RDS PostgreSQL database is experiencing high concurrency during a peak sales event. Occasionally, users report incorrect data being displayed due to concurrent updates to the same records. What is the best solution to ensure data integrity under high concurrency? A. Use serializable isolation level for all transactions to prevent concurrent modifications. B. Use optimistic locking with application-side retry logic. C. Implement a queue system to serialize incoming requests to the database. D. Migrate to Amazon Aurora and rely on its distributed nature to handle concurrency. Your RDS MySQL database is deployed in Region A with multi-AZ enabled. To comply with business continuity requirements, you need a disaster recovery (DR) setup in Region B but want to minimize costs. What is the best approach? A. Create a cross-region read replica in Region B and promote it to primary in case of failure. B. Use AWS DMS to replicate data in real time to a database in Region B. C. Take frequent snapshots and copy them to Region B for manual restoration during a failure. D. Deploy a second RDS instance in Region B and set up bidirectional replication. You manage an RDS PostgreSQL database that experiences unpredictable spikes in traffic during promotional events. These spikes cause query timeouts, even with read replicas enabled. What is the most efficient way to handle this scenario? A. Switch to Amazon Aurora serverless for automatic scaling during bursts. B. Add more read replicas and configure them for load balancing. C. Prescale the RDS instance to a larger class during the promotion. D. Use Amazon Elasticache to cache frequently accessed data. You are tasked with migrating a 10 terabytes RDS MySQL database to an RDS PostgreSQL database to take advantage of PostgreSQL features. The application cannot tolerate significant downtime. What is the most suitable migration strategy? A. Use AWS DMS in full load mode, followed by ongoing replication for minimal downtime. B. Take a snapshot of the MySQL database, convert it, and restore it as a PostgreSQL database. C. Use an ETL pipeline to manually migrate data in batches. D. Migrate the database during a scheduled downtime window, and verify the data afterward. You are designing an RDS PostgreSQL database for a healthcare application that must comply with HIPAA regulations. Which steps should you take to secure the database? 98. A. Enable encryption at rest and enforce SSL/TLS for all connections. B. Configure database auditing, encrypt backups, and use IAM for database authentication. C. Deploy the database in a private subnet, enable VPC flow logs, and use AWS WAF. D. All of the above. Your multi-tenant application on an RDS MySQL database is experiencing slow query performance. Analysis reveals that some tenants execute long-running analytical queries that block other users. What is the best approach to optimize query performance? A. Enable query caching for frequently accessed queries. B. Partition the database tables by tenant ID to isolate workloads. C. Use a read replica dedicated to analytical queries for high-traffic tenants. D. Increase the database instance size and tune the buffer pool. Your RDS SQL Server database is configured with multi-AZ. During a primary instance failure, a long-running transaction is aborted, leading to data inconsistencies. How can you address this issue? A. Use database snapshots to recover the state before the transaction started. B. Enable distributed transactions to ensure consistency across failover instances. C. Configure your application to retry transactions after failover. D. Increase the write timeout to allow the transaction to complete before failover. You manage an RDS PostgreSQL instance in Region A, which is required to comply with GDPR's data residency regulations. You need to set up a cross-region disaster recovery (DR) solution in Region B, but must ensure no sensitive data crosses regional boundaries. What is the best approach? A. Create a cross-region read replica with encryption to secure sensitive data. B. Use AWS DMS to replicate only anonymized subsets of data to Region B. C. Store snapshots of the primary database in Region B, but restrict access to sensitive tables. D. Use Amazon Aurora Global Database with fine-grained IAM policies to restrict access in Region B. Your RDS MySQL instance supports a content management application with a 90/10 read-to-write workload. During peak traffic, the database frequently reaches its connection limit, affecting performance. What is the best solution to scale this workload efficiently? A. Enable auto-scaling on the RDS instance to handle more connections. B. Use Amazon ElastiCache as a caching layer for frequently read data. C. Add multiple read replicas and configure application-level load balancing. D. Migrate to Amazon Aurora for better scalability and performance. Your RDS PostgreSQL database supports an analytics dashboard, but query performance has degraded significantly as the data volume grows. What is the best approach to improve query performance without migrating to a data warehouse? A. Partition large tables by date to reduce scan times for analytical queries. B. Create read replicas and route all analytical queries to the replicas. C. Increase the database instance size and enable enhanced monitoring. D. Use Amazon Athena to query the RDS database directly via federated queries. You manage an RDS MySQL database for a multi-tenant SaaS application. To enhance security, you need to enforce tenant-level isolation for database access while allowing centralized management of credentials. What is the best solution? A. Create a database user for each tenant and manage credentials manually. B. Use IAM database authentication to manage tenant-specific access. C. Implement logical isolation using separate schemas for each tenant. D. Deploy a separate RDS instance for each tenant to achieve complete isolation. Your development team uses RDS MySQL instances for testing purposes, but costs have escalated as multiple environments are required. What is the best way to reduce costs while maintaining functionality? A. Use RDS on-demand instances with smaller instance sizes for all environments. B. Switch to RDS reserved instances to reduce the hourly cost for all environments. C. Use RDS multi-AZ for production but switch development and testing environments to Amazon Aurora Serverless. D. Migrate development and testing environments to local databases on EC2 or containers. Your RDS PostgreSQL database contains personally identifiable information, PII, that must comply with GDPR's right to erasure rule. How can you design the backup strategy to ensure compliance? A. Use automated backups with default retention policies and delete PII manually when requested. B. Enable database snapshots and use a custom script to delete specific PII data from the snapshots. C. Use AWS backup with lifecycle policies and implement encryption for all backups. D. Disable automated backups and rely on application-level data archiving for PII. You want to monitor query performance on your RDS MySQL instance to identify slow queries and optimize them. What is the best approach to achieve this? A. Use Amazon CloudWatch logs to store and analyze slow query logs. B. Enable performance insights and analyze the dashboard for bottlenecks. C. Install a third-party monitoring tool on the RDS instance. D. Use enhanced monitoring and integrate metrics with an external visualization tool. Your production RDS PostgreSQL instance is currently running in single AZ mode, but you want to switch to multi-AZ for high availability without downtime. How can you achieve this? A. Create a multi-AZ read replica and promote it to primary during a maintenance window. B. Modify the existing RDS instance to enable multi-AZ deployment. C. Export the data, create a multi-AZ instance, and import the data back. D. Use AWS DMS to replicate data to a new multi-AZ instance in real time. You are tasked with designing an RDS solution for a global application with a user base spread across multiple regions. The application requires low-latency read and write access to the database in all regions, and strong consistency is essential for real-time user transactions. What is the best approach for database deployment? A. Use Amazon Aurora Global Database for cross-region low-latency reads and writes. B. Create a multi-AZ RDS instance in each region, with cross-region replication for writes. C. Use Amazon DynamoDB global tables for low-latency access and replicate the data to RDS for transactional processing. D. Use RDS read replicas in each region and route writes to the primary instance in a single region.